Hi everybody, this is Mr. Foley, and welcome to 1.4. We're going to learn how to do electron configuration. Have your periodic table out and a smile, and let's see what we can do. All right, so electrons are arranged oddly, so they're in clouds, and we want to make sure that we can tell where those are. The number of electrons, remember, is going to equal the number of protons, unless it clearly states it's an ion. Okay, so it will tell us somehow or another, right? There are four types of clouds, and I'm going to, I'll label this as I go. Let me make these a little bit thicker and darker. Here we go. Okay, so the first one is the S, which is the sphere shape. That's this right here. This whole block and this guy. Okay, so S is a sphere shape. It's the first two columns, right? Column 1, column 2. And it's helium. Not helium's column, just helium. They hold at most 2 electrons. Group P is the dumbbell shape. Bum, bum, bum. Okay. Boron, right? So here's boron, all the way down to neon, and below. It holds 6 electrons. Okay, now here's something that helps you figure out it holds 6. Well, I suppose I could make my pen a little smaller now. Let's go to smaller world. Smaller world. Whoa, that wasn't the smaller world I wanted. So here's 1, 2, 3, 4, 5, 6 columns. Remember, S holds 2. There's 2 columns, right? So counting the columns tells you how many. D is a complex shape, which is all you need to know. And really the shapes you don't need to know as much, but just to give you an idea that they're clouds, they're weird. D is the crossbar. I call this crossbar right here. Here's D, the yeller. This is D. Okay. Holds 10 electrons, has 2 exception spots, which we'll get to later. And those exception spots are in D4, 1, 2, 3, 4, da-na-na-na, and D9, da-na-na-na. So we got to be ready for those. F is even more complex. I put complexer to be funny. They're the bottom 2 rows, and they hold 14 electrons. Dun, 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 dun. Okay. So, oops, and I'm looking at a bad periodic table online. I'm glad I gave you guys a good one. Good. Okay, I got a good periodic table now. All right. An electron configuration has 3 parts. So the 3 parts will be the first part, dun, 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 coefficient. That's the 8 in this case, right? Let me change my color to the next one. So that tells us the energy level, okay? That tells us the row on the periodic table. D is off by 1 and F is off by 2. So let me just pull this up here if you're looking at a periodic table. So I'm going to erase these things on here. You don't want to erase them on yours, but just so I can talk a little better. So if you look at your periodic table and you look at the thing on, on 2A, okay? On 2A, this is beryllium, okay? So beryllium is going to end in 2s2. And this 2 says, hey, I'm on 1, 2. I'm on the second energy level, okay? So if I was looking at magnesium, which is right here, its coefficient would be 3, okay? Now, when I'm looking at the coefficients here, see how this is 3D, 4D, 5D, 6D, but really, this is on 4, 5, 6, 7. So it's off by 1. So you need to remember that it's off by 1, okay? If you look at your periodic table, again, it's better than mine, your periodic table, we have number 55, 56, 57, and then this is 58, okay? So notice how this is on 1, 2, 3, 4, 5, 6. This should be, you might think of it as being 6F, but it's 4F. Even though it's on the 6th level, and we'll get into that a little later, but it's on the 6th, but it's 4F, and this guy right here is 5F. Okay, and it's labeled right there, okay? So this helps quite a little bit if you look at it. So remember the row, first row 1, second row 2, third row 3, fourth row 4. Again, there's not a P1, so second row 2, well, where's my writing? Second row 2, third row 2, fourth, third row 3, fourth row 4, fifth row 5, and so on and so forth. But D and F's are off a little bit. So titanium is atomic number 22. It ends in 3D2. It should be on the 4th row, but it is 1. Well, it should be on the 4th row, but it is not 1. It is 3. Okay, so, and then this, when I was in school, if you got all D's, you failed. So there was a kid that got all D's in my class, and they held him back in elementary school, okay? And the poor kid had to repeat 4th grade, okay? Oh, sad, right? Europium, atomic number 63. So let me show you where titanium is. Titanium is like right here. Europium is like right here, okay? So that's the D and the F block. So all D's, you get held back in Indiana. All F's, they made you repeat a grade. So there was a kid named Buddy. You'll hear more about Buddy in my life later on. Buddy got all F's, and he was in 4th grade, and they put him in 3rd grade. They moved him back. I don't know why they did that and thought that was a good idea, but they did. Okay, so you drop a grade, so that means you're off by 2. Okay, the block is the letter. This is the S in this case, where it is in the periodic table. So this is S, P, D, F are the blocks. So if I ask what block is it, you can do that. Superscript, so again, if I had 8S2, this up here is my superscript, okay? Column 1 is the first column, column 2 is the second. So if I have 8S2, that means I'm looking at 7. Oh, I guess I went to 8. I went too far. So let's pretend I had, I'm going to get rid of the 8 here. Let's say I had 5S2. So what the 5 means is I'm on the 5th row. 1, 2, 3, 4, 5. I'm in the S block, and the 2 tells me I'm in the second one of the S block. So 5th row, 1, 2, 3, 4, 5. S block 2 is strontium, which strangely is circled on the periodic table I found on the floor. All right, so let's do some electron configurations, and these get crazy. When I do these, I don't expect you to be perfect at them. I expect you to not understand them. I expect you to follow along, and we'll do more in class, okay? So what we're going to do is we're going to go across the periodic table and take care of everything. That first row right there is the first energy level, S block, and there's 2 of them. And I'm going to keep going until I get to lithium. Then I'm going to be on the second energy level, S block, 1. Why 1? It's the first column in the S block. And I'm done. Woohoo! That's it. Phosphorus. So I'm going to erase these and look at them again. Again, it's very repetitive. The first row, 1S2. Second row, that's a 2, I'm sorry. S block, remember this is the S block. I have 2 of them to get to phosphorus. 1, 2. Okay, now I have to go from number 5 to number 10. Still the second row. Now I'm in the P block. P1, 2, 3, 4, 5, 6. That's not right very well. Now I'm in the third row. Na and Mg. Third row, S block, 2. So I'm kind of going block by block. Still on the third row, but I only go 3. I'm in the P block now, but I only go 3 to get to phosphorus, which is right here. Okay, good. Now we get to do the bad titanium singing. I am titanium. So again, first row is 1S2. Right, 3 and 4 are 2S2. 6 through 10, still the second row. Oops, why went my second row? P block, and there's 6 of them. I'm going to titanium right here. Next one is third row, S block, and 2, right? 1, 2. Third row, 1, 2, 3, 4, 5, 6. Third row, P block, 6. Fourth row, S block, 2. And I'm still in the 4th row, but remember, it's 3D, not 4. Remember the D is bumped off by 1, right? 3D, and I'm 1, 2, 2. There's titanium. I am titanium. Okay, short form, aka core notation. So this has a bunch of names. Short form is name number 1. Core notation is name number 2. And noble gas notation is name number 3. So this is just a way of writing this shorter. See how titanium got long? So we're going to do some shorter ones. So we're going to write the proceeding noble gas. I'm going to put noble gas in brackets here because we have to put it in brackets and start from there. So I'm going to look for aluminum. Erase my periodical table again. Find myself some aluminum. Boom. Aluminum's number 13. My preceding noble gas is neon. So write neon in brackets and then continue. So neon took care of this, 11 and 12. Third row, S block 2. And then I got 1. Third row, P block 1. Short form. Xenon. Okay, xenon kind of mean, right? Now, xenon is a noble gas. Uh-oh, noble gases are the last column, are the noble gases. I almost forgot to tell you that. That's kind of important, okay? So xenon is over here. My preceding noble gas is krypton, so I don't get to use xenon. I use krypton, which is more fun to say. Krypton takes me up to 36, so now I have 37 and 38, which is 1, 2, 3, 4, 5. So it's 5s2, 5s. I just put 6. I don't know why I did that. 5s2. And then I have this D block right here. 4d10. And if I count them out, there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I'm back up to 5. 5p. 1, 2, 3, 4, 5, 6. So if you have memorized what they are, it helps. Okay. We're going to do some orbital diagrams now. This is what orbital diagrams look like. Notice this is just like phosphorus. On my page break, I think went funny on me. Phosphorus' electron configuration is 1s2, 2s2, 2p6, 3s2, 3p3. And notice how this is really saying the same thing, just with some arrows, okay? The arrows represent electrons. Orbital notation. Boxes represent places electrons, arrows can be. Boxes hold at most 2 electrons, 2 arrows. Electrons fill the boxes in a subshell by having the same direction and even spreading. So this, again, we're going to kind of do it on our own. Chlorine is right here, number 17. I'm going to super fast write the electron configuration. 1s2, 2s2, 2p6. See, chlorine ends in the third row. 3s2, 3p5. Same format we did before. Notice this is row 1, row 2, row 3. I'm in the P block, and there's the fifth one over. 1, 2, 3, 4, 5. So now I'm just going to put the electrons in. 1, 2, 2s2, 1, 2, 2p6. This is how you fill them. 1, 1, 1. So everybody gets 1 before anybody gets 2. Oh, isn't that nice? So sharing. Oh, kind. And then down, down, down. That would be 6. 3s2, up, down. 3p5, up 1, up 2, up 3, down 4, down 5. There's chlorine. Okay. Carbon. Carbon's number 6. Nice short swimple. It's very swimple. 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. And notice how these are both up, not paired. Not paired. Okay. Exceptions to electron configurations. All right, so I remember this as D4, D9, D don't. Okay, so you're never allowed to have D4, you're never allowed to have D9, so the D don't is kind of fun. Purpose of electron configuration is to show where the electrons are. Electrons go to the lowest energy level. Remember, lowest energy would be most stable. Full lowers the energy, that's the most stable. Half full lowers the energy. A bit more stable, I'm going to change this, than nothing. And I'm going to add less stable than full, because that seems a little bit ugh. Okay. Anything else is unstable. So I remember it's full, half full, off full. Oh no! Can I do it in time? Chromium's expected. 1s2, 2s2, 2p6, 3s, 3p. So the expected would be up, down, 1, 2, 3, 4. But what really happens is, if you see, let me get my thing here. You see how this is full and this is not full? What happens is it promotes one of them up. Okay, so when it promotes it up, that means I end up with S1 and D 1, 2, 3, 4, 5. This makes it half full, and that's awesome. So remember, you have full. Yes! Whoa! Half full, and then we have awful. So by making this half full and this half full, life is good. and we are done. Toodles.